Thank you. This is OWASP Top 10 for LLMs. Let's dig in. For those of you that don't know, OWASP stands for the Open Web Application Security Project. And they issue a lot of guidance on everything from web applications to red teaming guides, and now LLMs. Now this list isn't new at all. It came out years ago. But it was recently revised in 2024. They take a look at different things. They look at the potential impact, the number of times these issues are discovered in the wild, and then they rank them. And that's the really important part here. Because if you take care of all that, you're going to end up taking care of the Pareto principle, right? 80-20. So you take care of a lot by taking care of just a small slice. So here I am leading a team, and we're building AI-enabled stuff. But I needed to get up to speed on the LLM stuff. And when I did, I started seeing things that reminded me of the traditional, or the prior, or still existing OWASP Top 10 for web applications. Because insufficient logging and monitoring might tie closely to monitoring your prompt, sanitizing your inputs. I'd argue that prompt injection ties closely to both injection and insecure design. It's pretty clear that to know one sharpens the other, right? So I always wanted to do a lightning talk, and that means I've got 20 items to cover in 30 minutes. Bear with me, things might get a little weird. My name's Dave Hawthorne. I'm Director of Engineering at O3 Solutions, where I'm responsible for DevOps, data, and security. By the way, we're headquartered right here in Birmingham, and I always love getting back here, even though I live in Asheville. We build industrial construction project management software. We deal with some of the biggest companies in the world, and it's a lot of fun. So today I'm going to talk about a fictional company, Iron City Labs, that didn't ask themselves how to balance AI innovation and business risk. When they asked themselves the question, they found out that the real answer at the end of the day isn't whether to use AI, it's how to do it without burning your business to the ground. Iron City Labs failed to understand the underlying technology and how it works, and that was their critical mistake. At the end of this, you're going to understand how to secure your web applications, or at least get a start that are AI enabled. You, Marcus, Sandra, and the board are going to get pretty far, but let's take a look at their worst week ever. On Monday, an AI research assistant leaks confidential client data. By Tuesday, we've got a code generation tool running amok and spikes our API costs by 10x overnight. That really sucks. Content assistant starts spreading misinformation. I'm not going to drop the F word. Well, I will. Fraud. And then finally, we've got a legal cease and desist from our clients, the government, and everyone else. So that's 3 days, 4 problem sets. Are we going to be able to rescue this? I think so. Who's gotten the 3 a.m. call? Well, we got to take a look at why that happened. So we're going to understand how bad data got in. We're going to understand how bad data got out, data that people shouldn't have seen. We're going to talk about how we lose credibility in trust and governance. Each theme reveals different vulnerabilities, and they're all tied together in a way. They may look different, but they smell the same. Like I said, anybody ever have that 3 a.m. call and it gets worse? Oh crap, Sarah, it's not just one client. What do you mean? It's all of them. So let's dive in. I'm going to kick it off with system prompt leakage. This is when you treat your system prompt like an environment variable for your containers and your images or your web apps. We don't store connection strings in our application. We store them as secure variables or configuration files. So there's 2 key issues. We've got hard-coded connection strings. And then look at number 1 down here. Y'all probably can't read it. It says, do not share this with anyone. Here's our budget. You can bully a LLM like you can bully a person. If you can phish someone, you can do it to an LLM. We hard-coded our connection strings, and we told it not to disclose information. Best practice, never store your secrets in system prompts. No tool can fully protect against it getting out because of the nature of how LLMs work. If you had prompt injection on your bingo card, congratulations. You can mark that one off. This is probably the one that we're all familiar with the most because it's fun to try to jailbreak an AI. Using instructions, our user was able to get that budget number we saw in system prompt leakage. So they're really related together. Now this is an injection attack. We've seen this before with web applications, with SQL injection and URL hacking and other wonderful things that I do on the side so that I can have fun. Now there are tools that guard against this. LLM Guard is open source. It's probably the biggest one out there. It's got 4.1 million downloads so far on GitHub. Now, or on their site. If you're worried about any tool I mention and writing down judiciously, don't worry about it. I've got a GitHub repository. I'll give you a QR code right after this. And of course, I got to pay my Bobby Tables tax. Somebody knows what I'm talking about. Poor Marcus, our security guy. He's seen all this before. Go ahead and take your facepalm. When you see A and a number, that actually comes from the web application OWASP. We saw injection, we saw security misconfiguration because we disclosed our secrets. We didn't think about our threats before we deployed to production or started coding even. And we've got broken access control. But it gets worse. Because wait, we're not just leaking training data, it's leaking client conversations from the past week. We built a pipeline to a data breach. And each vulnerability amplifies the others. These next three I'm going to cover are all interrelated. They're all, you can chain all of these together real easily. Essentially what happened was we had research documentation and we were feeding that RAG application all of our client conversations. But the thing to understand that's really critical is that's not how LLMs work. They aren't databases, even though they're vector databases for RAGs. It didn't learn patterns. It memorized the data and regurgitated it. Because of that, conversations got leaked. And then finally, the RAG system was also cross-tenant. So let's get into data poisoning. This is when you don't sanitize your data or someone injects malicious content into your knowledge bases or your foundational models that you're building, that you take and then build off of. This can happen a lot of ways, such as hidden text in resumes, binary encoded data that slips in. That's LLM2, sensitive information disclosure, combined with data poisoning. The model didn't just learn patterns, it memorized sensitive content. Think of vector databases like traditional databases, but they store mathematical representations of that data called embeddings. The security principles are the same. You gotta have access controls, you gotta have data validation, and proper isolation to make sure you don't get a data breach and fines. So let's talk about vector embedding weaknesses, or why this is important. I met a cool guy over at B-Sides, Steven. He was one of the authors of this report. And the one I want to point out down here is that 71% of RAG infrastructure is completely unprotected. In other words, if you're paying a subscription fee, stop, you can get it for free, right? and all of your clients' data. Even scarier, we're not far behind China or all the others combined, right? We're the second highest, other than others. There are so many ways to exploit each risk. Over here, I've got our attack surface. It starts with a user prompt. goes out to the vector database, talks to the LLM, and gives you an answer. We've already talked about cross-context data leakage, but I want to talk about embedding inversion attacks. Those are pretty cool. So what you do is you reverse engineer the embeddings, okay? That serialized data or encoded data that's based on mathematical similarity. But mathematical similarity does not equal an authorization boundary, right? In traditional databases, you might store a user ID next to some data and then join that with your role-based access controls. That's not how this stuff works. What it's doing is it's thinking in 3D and saying this is related to that, which is related to this. That's 2 hops away from data they shouldn't have seen. They don't understand business context. Semantic search finds similar content regardless of access rights. There is no permission-aware retrieval in a standard vector database. So, what do you do about the RAG issue? You don't wash your RAGs, although you should for data poisoning. There's a great tool for sanitizing your RAG databases that's put out by Microsoft, and it claims to get 99% data accuracy of detecting PII and PHI. What we need to do with this is go and understand the limitations that you have with vector databases. Be conscious of which layer you use for authorization. For me, at least, in my example that I talked about before with a user ID, if I had sensitive data, maybe a vector database isn't the right place to store it, right? Maybe I should put that in the database with a vector data type and store my embedding there for my client conversation next to my user ID and use my role-based access controls. Essentially, what got them in hot water is for efficiency's sake, and I'm using finger quotes here because every time I hear that, it's cost-based. They decided to put all that in their LLM, in their database, and that was their critical mistake. And this is like a traditional vulnerability, authorization bypass. No permission-aware vector access controls in shared databases. There are paid platforms that claim they have secure vector search, but in the example I just gave, you're already using your relational database, so why pay for that? So, to recap, never treat your prompts like they're safe inputs. Put something in front of that, like LLM guard, to detect unsafe or malicious content. Never store secrets in your system prompts. They are prompts, not configuration files. Sanitize your data, check it for PII and PHI that shouldn't be there using different tools like Microsoft's one that starts with a P, but I'm blanking on it. I'll give you a GitHub. So that's just one day. That's Monday. Tuesday is going to be a lot worse because it's going to hit them where it really hurts, their wallets. Poor Marcus, poor Sandra, double facepalm, which leads us to section 2, Tuesday. Asset protection and abuse prevention. Now in security, we like to say the most important asset we protect is people. It's even on the CISSP study guide. Sometimes our budgets too. So how do we get that 47K bill where we 10x our API costs? Well, we ask a code assistant to generate one Python script. Next thing you know, you've got an email from the board saying, explain this immediately because they're copied on your budget alerts for your cloud infrastructure. And that's no fun to explain. Let me ask you a question. How many of you were vibe coding before ChatGPT? Stack Overflow, right? Would you auto-deploy from Stack Overflow? No! No, I do believe you get fired for that. So I'm going to let you all decide if this is a data breach or a decentralized surprise backup. Here's what happened. We got our code assistant going and creating a script to back up our database user analytics, by the way. It went and started thinking like a staff engineer because it didn't just generate the script, it thought about the system as a whole. You're going to want notifications. You're going to want to optimize your indexes. And that's a problem, right? Because what we ended up doing was giving it too much agency and it did it all. You don't give read access to every database, right? Or write access to any database without some controls around it. You surely wouldn't let it access production if it to execute these index optimizations because now you've crippled production. Your innovation has halted because you're responding to incidents. So here's the final result. It worked too well. Your database is now optimized and backed up. Awesome. Oh, wait. It sent an email. And it didn't just email us. Because it had read access to stuff it shouldn't have, it said, hey, maybe your customers want to know, too. And that's a lot of bad explaining to do. That's LLM5 improper output handling. When you trust AI output like it's human-reviewed code. Now, I'm going to go over the business impact now, because this has broader impact than just when we code. First off, you wouldn't give Toby from HR access to prod, much less a new hire, right? Next up, we got the email issue, because your clients probably knew you backed up the user analytics database before you did. But it gets worse. They know what data you were collecting, and somehow you collected the wrong thing even though you tried not to. So now you're paying 4% of your revenue in fines. Better up that 47K. And then last but not least, as I mentioned earlier, you spent time fixing this instead of delivering value to your clients, right? Features, shipping features. Combine that with excessive agency, and you've got a time bomb. Because Marcus just discovered that we're automatically executing anything that AI generates, and that's not fun. $47,000 is the least of their worries now. And here's what we already knew. If you had human in the loop on your bingo card, you could cross that off too. We knew that this was identification and authentication. We knew it was authorization. We knew it was injection. We knew it was software and data integrity failures from web applications. We wouldn't do that with our web applications, right? We wouldn't give it unfettered sysadmin access, right, from a web application. Why would we do it for an AI? Whether it's looking over someone's shoulder or it prompts outputs, there's a lack of approval, and that's the problem. Next up is API bombing. The vulnerability or risk I'm about to mention uses CodeGen for example, but it can happen to any. And it's an example of unbounded consumption, because traditional denial of service attacks cost bandwidth, and if you're on serverless architecture, money, right? Or auto-scaling, money. LLM attacks amplify that cost. This stuff isn't cheap. So here's the setup. We had a smart code assistant that improved our code through iteration. You can probably figure out what happens next after it optimizes itself into a recursive loop. It's reviewing its own work. Yeah, infinite loop. But there's some things you can do to mitigate that. You can use rate limiting. We do that with our web apps, right? Right? Go do that. We've got token analytics and alerts. When these things first came out, that was a big deal because they were so expensive. But as the cost goes down, you still need to pay attention to that. Budget alerts, I already mentioned. And then circuit breakers, where when anomalous activity happens, it pulls the plug or restarts the service or something else, blocks the IP address. So monitor, log, understand what you've got going on with your AI and that flow, That way you don't end up with $100,000 in API costs because our revenue is so low. Yeah. So $100,000 in fines. Yeah. So let's talk about supply chain surprises. I was at NG Atlanta years ago, and we were all talking about NPM security, Node Package Manager, right? And the thing we learned about Node Package Manager is that, anybody remember LPAD when like a quarter of the internet went down? Google LPAD, because that was a package that the developer changed and everybody was using it. And it caused a serious issue with the internet. So what we've got here is a compromised model that's injecting subtool vulnerabilities, and the result is 720 code commits over 3 months requiring manual security review. How is that different from any other software supply chain attack? It's just new tech. The good news is OWASP is building Cyclone DX, which will give you some provenance and make sure that your model isn't compromised. If you're going out to Hugging Face and just downloading blindly, you're going to have a bad time. There's also utilities you can put in your CI/CD pipelines. Down there, vulnerable and outdated components from the traditional web apps. All right, so AI security isn't just about preventing attacks, it's about enabling sustainable innovation. Security is there to raise the business's value. But we've lost customer trust, we've crippled our development velocity, and we've lost market position because competitors with better controls than Iron City Labs are shipping features while Iron City Labs recovers. Nobody wants that. I'd rather be doing cool stuff. And here's the thing. I believe security is a competitive advantage. It can create revenue and draw in deals. And the larger the company is, I'll let you in on a secret. They want to have access to their data, and they want to be able to trust that it's secure. So when you go and do something like this, and tell everyone that quantum computing is going to render all traditional security obsolete on Tuesday, and that you're actually offering great migration services and selling that, it's going to look really bad on you, right? And here's the thing. The AI wasn't wrong. It was 97% certain that implementing blockchain-based AI will solve all cybersecurity challenges. Well, that's a little bit of hyperbole. But it was 97% certain. But AI doesn't know when it doesn't know, because confidence isn't correlated with accuracy, just like precision and accuracy aren't correlated either. Stormtroopers can be very precise, but they tend to miss unless it's Leia in Return of the Jedi. So there you go. Confidence isn't correlated with accuracy. The next up is bias. LLMs are non-deterministic. You can write code and get the same answer, right? 1 + 1 always equals 2. That's how code works. But LLMs are non-deterministic. You can ask it the same prompt and get 2 different answers. So here's a sample question from an applicant tracking system that Iron City Labs pays for. And this applies to your apps too. Our ATS, or applicant tracking system, is going to suggest a correct answer for each candidate when they review their application. Eric got told that he should implement React for enterprise stability. Maria got told, use HTML and CSS. Not really cool. Jalen's going the open source route, and to do open source right, you got to read the source. The thing is, Eric, Maria, and Jalen gave the same answer on their application. And as a hiring manager, who looks smarter? Who looks like they can do the job better, right? Best. Because that's the thing we're supposed to consider. That's the only thing we're supposed to consider. But the LLM doesn't know that. Well, it knows it. It just doesn't think that way. The AI amplified systemic biases in tech recommendations. So what started out as a statistical bias became operational discrimination. And here's the thing, everyone, that I want you to understand. When you look at AI and you've got bias, AI is going to amplify that bias. Seen it time and time again. There's a great book by Kathy O'Neill called Weapons of Mass Destruction. That's where I cribbed this case from. If you want a great book that will really shock you and worry you, pick that up. It's super interesting. I see a head nodding here. Yeah. But who's liable, right? Let's say the Department of Labor comes. Who's liable? You are. There is actual case law where companies using SaaS software that they didn't develop to screen applicants were held liable for systemic bias in the applicant tracking system. All too often, we go to conferences and we come back thinking we can change the world. It's like summer camp or a retreat. You've solved the world's problems, you know what to do when you get home, and you're fired up to get in gear. And then reality sets in one day later when you're going through your tickets, where you're going through your backlog, and you say, how am I going to do this? The answer is actually pretty easy. I'm going to give you a strategic framework with 3 items you can do tomorrow. Well, Monday, right? Everybody's coming back for day 2. First off, inventory your assets. Know where your data is going. Know where your data is coming from. Understand your pipelines. Know what they're doing, okay? Internal tools, CI/CD, anything that ends up touching that LLM, write it down. Because it's going to do 2 things. It's going to make you faster when the LLM, if Iron City Labs had done this, their 72 hours with that code assistant, or all those 720 commits, they'd know their exposure. They'd know how deep they're in the suck. Next up, because you understand what you're doing, you can then go and start using a risk to impact matrix. High, right? High risk, high impact. We're going to look at that immediately. Low, standard security should be sufficient. Then start asking yourself strategic questions and making decisions. You don't have to be a security expert to understand that if a data breach happens, how am I going to explain this to reporters, right? If I'm staring a journalist in the face, it's going to sound a lot better that we did a risk assessment on our AI features. We had an inventory of all of our assets. And this is an anomalous thing that occurred. Sounds a lot better to a reporter than we screwed up, we don't know what we're doing, this is new technology. Then pat yourself on the back and go read the OWASP Red Team Guide for LLMs, because that'll enable you to take this assessment even further. And if you want to learn something, the best way to do it is with a simple project when you're coding, right? Well, the best way to learn this stuff is to red team it. I don't know about you, but I like red teaming. Red teaming is where you go offensive. So with that, like I said, I've got a GitHub repository with a README, slides are up there, everything. Here's the QR code for it. If you want to get in touch with me, just look for David Hawthorne on LinkedIn. My picture's right there. You can get all my contact details there. I'm also Shell Ninja, even though I'm not too good with a terminal, over on X and Blue Sky and all the other socials. Thank you all very much. And remember, traditional security principles apply to everything. Security failures cascade into strategic problems. Build accountable UI. apply some rigor, the same rigor you use for business critical systems. Everybody go out there and engage. Make it so. Thank you.
David, you want to take any questions?
Sure. I got time. Yeah, 2 or 3. If anybody wants to hang out, we're going to do some questions.
Any question?
Any questions? Over there. Let's get Ed with the microphone. That way you show up on the internet. No pressure.
Sorry, I'm Manoj. I'm a student at UAB. So I've been using these vibe coding tools like Cursor and Windsurf, and sometimes like when I just wanted to use the OpenAI API key, so I just put like OS environment to retrieve that. But while I was typing, I could see that LLM was itself generating an API key. So I don't know if it worked with that key, but I was thinking like even though the cursor says it doesn't read any environment variables or API keys when it integrates our complete code base, to help us. But I'm not really sure if it's, in back trying to train itself with the keys or maybe, on the security context of that. Yeah.
So if I understand the question right, you have an API key for OpenAI, you put that into Cursor, and you're wondering if that's secure.
Not exactly. So like before I put the API key, I just typed in the code file that I'm going to import an API key here. I was using InFiscal, but just I was typing, it was showing me the the auto completion of an API key, actual API key. But I've not completely used that API key. I'm not sure if it's going to work. But I was thinking like even though Cursor says it's not going to read environment variables or something related to security context of keys and all, but does it mean like these AIs do really read or are train themselves with these keys or become a threat with the security of our core base?
Let's follow up afterwards. Let's meet up out there.
Thank you.
Over here.
I'm curious because I want to hear you talk more about your favorite topic of red teaming. Is the technical skill set or the social influence skill set on the red team seem to be more successful in finding vulnerabilities in LLMs? Because obviously there's implications for both the SSH shell hackers and the people who can kind of bully and persuade. What seems to be the more interesting skill set at the moment?
In the context of LLMs, what I find most interesting is what people are doing with embeddings and hidden data. So what I alluded to earlier is where you encode data, you give it the key to unlock that data, and then you send it another payload, and all of a sudden you've exposed all your data, right? And I find those attacks really, really interesting and fun to mess around with in my own personal development. The social aspect, the thing about the social aspect that I'm finding is that anybody can do it. You don't need to be technical. You don't need to get out a calculator like we used to when we were working on assembly, right? You don't need to understand the technology. You need to understand how it thinks. And the more you use the technology, the better you're going to get at the social aspect, whether or not you're red teaming or just the average user. Great. Anybody else? Cool. And thanks y'all so much. Really appreciate it.